Okay, can you see my presentation?
Yes.
Excellent. So welcome to the third Edge Discovery event. We had very successful events earlier. One of them was the general event for many verticals, and the other one was dedicated to the drones. And this time we will actually look how to unlock the edge value for spatial computing and gaming. So the idea is to leverage the edge to get closer to where people and the objects are connected, to make the 5G edge specialized and ecosystem programmable to support the spatial computing and gaming, and also to tap into the enterprise and consumer application ecosystem. So we start the event, and maybe a little bit recap of 5G, because we are talking about the edge of the 5G network, or 5G advanced. So with 5G, actually, as was defined in release 15 and 17, we enabled new market segments such as industrial and logistic enterprises to start benefit from the ultra-reliable, low latency and high data rate capabilities of 5G. We talked about higher speed to the more users. We talked about 20 to 50 billions of things, sensors, cameras, drones connected by 2025 with 1 million devices per square kilometer. And 5G is not only about high speed for entertainment. 5G can guarantee different levels of latency and reliability, and connect more devices than ever, enabling services that were previously imaginary. So 5G focuses on industry, on healthcare, transportation, on governments, on business, much beyond just the consumer industry. And this was 5G, and then we advanced it with 5G Advanced in release 18 and beyond, which is actually become the second half of the 5G era. And we actually used the 4E approach to provide new usage areas, new services to boost resiliency and operability. So we start with providing better experience. So the way that we experience connectivity is transforming extreme mobile broadband experience with bounded latency, with high data rates, and enhanced reliability. We are talking about 5G Advanced to make digital experience truly immersive, to empower us to engage with a distance, physical environment, and other people in new accelerating ways, and to create this new XR experience. 5G Advanced support features like resource allocation optimization, like mobility and beam management add-ons, with device power saving, with quality of experience enhancement through edge cloud capabilities and application awareness. And then we work to extend the coverage, so to improve the coverage and the uplink capacity. So there are still many white spots where no coverage exists, and 5G Advanced do more to extend the broadband connectivity into rural and undeserved geographics. It will provide lifelines to critical industrial networks, such as smart grids or whatever. And new categories of consumer wearable devices would link to the mobile network, benefiting from, for example, reduced capabilities, ability to provide extremely low cost, low data rate connections, and also using new beamforming technologies. 5G Advanced will even look to size, bringing fleet of drones into the network forward, while side-link technologies will enable the networking of interlinked devices. It will also bring mobile broadband to new classes of devices, for example, extended reality, reduced capability devices, new side-link innovation, reduced bandwidth operation, and open the 5G to new sectors. In addition, we work to expand to support high precision location presence and timing technologies. So really extending the role of the network into new area of supporting autonomous robots that we can optimize how we power, secure, and feed the world. A high precision location, for example, even indoor. I'm sorry for that. Even indoor, and presence and resilience timing technologies are actually key innovations which are claimed in this era. And this will expand the role of the network beyond communication. So it's not only that it will make navigation and logistics system more efficient, but it will be critical to the operation of, for example, driverless cars or autonomous robots or industrial automation system in the future. And enhancing the timing will be a boon to multiple economic sectors like finance that demand high degree of precision in transactions. And last but not least, we will extend also the network and make it the network-wide operation excellence with greater level of energy, all empowered by AI ML. So we'll be able to dynamically optimize the traffic allocation and to have zero touch orchestration of new services. And again, with AI ML, we will, of course, increase the energy saving in the network, and we all provide some excellence operation. So what is it about the 5G Edge? With the 5G Edge, we actually help also to get closer to people and connected objects.
Karen, I'm very sorry to interrupt, but I just lost your slides. I just clicked something and took your presentation away. Hang on, let me get your slides back.
You don't see my slides?
I accidentally did something and I took them away. Yes, and so yes, and I'm trying to give them, but you might need to reshare your slides. Apologies, this was entirely my mistake.
You don't, I don't really.
No, it was something I did. They were showing, but I just killed them.
So you need me to
reshare.
Reload. Okay,
Yeah.
I see.
Okay, good.
Yeah, we see your screen now. Yeah, this is a different deck
though. Wait,
I think this is the wrong screen. Yeah, there you go.
Okay. So now going now to the 5G Edge. With 5G
there we go.
Edge,
Sorry about that, Nurit.
No, don't worry. So the 5G Edge environment is characterized by close proximity, by ultra low latency, by high bandwidth, with location awareness, and edge computing, and provide also edge computing at the edge of the network with IT service environment, which really constitute a powerful catalyst for innovation and unparalleled experience. It is the keystone of the ultra-reliable, low-latency connectivity transformation and the all-digital mobilization of the enterprise industries. So IT economies of scale can be leveraged, allowing proximity, context, agility, and speed to be used for wider application, which can be translated into unique value and revenue generation. So we're talking about, for example, to be able to distribute computing for intense and local tasks. We're talking about real-time delivery of live on content, so we can take context information and location awareness that can be used to create higher personalized services which can be tailored to individual needs and performance. We can have interactive sensitive applications such as gaming, augmented reality, or indoor navigation located in close proximity to the users and can benefit from increased responsiveness as well as maximized speed and interactivity. You can also stay low latency where voice is delivered with minimal delay in near real time and can be ensured for critical communication, for example, for industrial environment. And we can have real-time analytic performed at point of capture and take corrective actions instantaneously taken locally. Furthermore, we can take real-time insight into the network and context information to really help to optimize the applications and enable new business opportunity towards these industries, metaverse and consumer applications. And the exposed information capabilities can meet the needs of the consuming application, then help them to proactively maintain the experience, and all of that while we're exposing simple and abstract information, which really hide the complexity of the network and the associated technologies. Also being aware to near-time capacity, for example, available at the downlink interface can help us, for example, to utilize maximize the utilization of the precious radio resources and accelerate the video delivery, for example, to improve the video quality and eventually the user experience. So if we think about MEC as a service environment which reside on top of the edge network, actually we have a local focal point where operators can collaborate with enterprises and application providers. It can enable a myriad of use cases across multiple sectors as well as innovative business opportunities. I think it is a powerful catalyst for innovation across traditional borders. So today we will focus on the spatial computing and gaming. We will try to examine how the MEC technology can enhance spatial computing and gaming verticals by improving performance, scalability, security, by providing information from the network that can help and foster innovation. A topic that we'll try to explore is about emerging trends, opportunities, challenges, and barriers, example of use cases and what capabilities we can expose from the edge of the network to help optimizing and accelerating these applications, some considerations maybe of ethical and social implications, and in principle about the future outlook. So let's promote better innovation at the 5G edge, especially today for the spatial computing and the gaming applications. So what is on the agenda for today? So we will start with keynotes from Leslie about edging ahead. And then we will continue with Alisa approach to metaverse. We will look at the emerging trends and the possibility with Santry from Alisa. And then we will go to next generation gaming at the edge with Josh from Verizon. And then we will continue about real world example of how the edge network has enabled spatial computing. And this will be provided by Matthias in Immersal. And then we will look into edge computing, which apply today gaming's market. And this will provide a case study by Matthew from EdgeGap. And then we will look at 5G extended realities, about streaming of XR, secured streaming of XR from the edge from Philip from HoloLight. And then, of course, it's nice to hear presentations and discussions or whatever, but what is better than to see a live demo? So Lawi will provide us a live demo of visual positioning in events using the network of course from Nokia. And then we will go for a panel discussion, which will be moderated by Leslie, and all the speakers will participate in that. And it will be about edge horizons, navigating future opportunities in spatial computing and gaming. And then at the end, we will try to learn and to have some to consider the next steps for the event. So with this, I want actually to hand over to you now, Leslie, to start the real content for the event.
Fantastic. Thank you, Nurit, for that spirited beginning to this exploration of the edge and spatial computing and gaming at the edge. So let me go ahead and share my slides. So for those of you who, whoa, new interface. All right. Let's see. There we go. So yeah, so for those of you who don't know me, I am Nokia's head of trend and innovation scouting. I'm located in Silicon Valley in California. So good morning. the sun is now up. That's great. And so my role within Nokia is to look outside the telecommunications industry. Oh, can everyone go on mute, please? I hear somebody flipping papers right quite close to the microphone. Thank you. They're still doing it. Okay. So my role is to look beyond the telecommunications industry at things that are happening outside from other industries that are going to require some kind of connectivity support, particularly some kind of connectivity change. And of course, things, other industries don't understand telecommunications at all. They build their technologies just assuming the telecommunication support is going to be there for what they need. And then they're surprised when, or sometimes we're surprised when there's actually not a very good match. And so I'm trying to make sure that we're designing the networks that are needed for these other industries and other entities so that we actually have a nice fit. between new technologies and the evolution of the technologies of our networks. So with that, I wanted to talk to you today about some of the things that I'm seeing that fit into this gaming and spatial computing rubric. However, when I sat down to actually put together my slides for this presentation and figure out what I was going to talk about, I realized that we have such a good roster of speakers here today. I am so excited about every single one of the people who's about to speak after me. Um, that their companies and their activities are actually they form all of my best examples of spatial computing and gaming at the edge. And I realized I really can't give their examples because they're going to talk about their examples in their presentations. So hang on, because we've got a couple of hours of really exciting content here for you. So I had to think, all right, what is left? What is left for me to talk about? So I thought, all right, let me set the scene then by casting a little bit forward into the future, and which is what I generally do anyway. So let's look at where the edge plays with spatial, and particularly with where XR and generative AI are going to come together, because that is actually something that is quite a significant addition to all the things that Nurit just described. So, um, where are we in particular with XR on the consumer side? Because XR, and when I'm going to use XR as a catch-all, well, largely meaning augmented reality, but augmented and mixed reality. XR today is very well established in the enterprise space, where you've got a limited footprint that you're covering, where you've got limited use cases, and you're generally working with a friendly client to make things happen. Quite often you'll have on-prem processing. To do that edge processing, you definitely have that very low latency and very high bandwidth that's necessary. So the bigger challenge actually for our industry is going to be taking that same kind of advancement and moving it into the macro networks to be able to support consumer, early morning, consumer implementations. So one of the things I'm doing is I'm looking at where are the signs of edge computing and need for edge computing coming from outside our industry at the consumer level. And one of the earliest examples of really true augmented reality is coming from the automotive industry and heads-up displays in cars. And I know this doesn't sound very exciting. It's been around for obviously, probably a decade at this point. But BMW, the work that they're doing in so many areas is quite forward-leaning. And so, here's a visual of the heads-up display that they have. Quite simple, low-key, not spatial, not integrated with anything, but it's giving you directions, it's giving you speedometer information, and it's
Leslie,
giving you, yes.
I'm sorry to interrupt you, but your slides are not changing.
Oh, can you see the BMW slide?
No, we can see the first slide with the title, and the presenter mode
Right.
is not on for some reason. Just wanted to let you
Okay.
know because
Thank you.
we were
Yeah, no,
obviously going
that's
into BMW already.
exactly. And I have on
Okay.
my screen it was showing. All right, this is getting exciting.
Okay.
All right. Thank you for that. All right, let me try this. Let's see. Okay, give me a sec here. And now, how's that? Can you see the BMW slide?
This is perfect. Thank you. Sorry
Oh,
to interrupt.
no,
This is better.
no. Oh, very important. Yeah, it's the fun of the new platform, or new to me anyway. Oh,
Absolutely. Absolutely.
absolutely. Okay, so here we are, BMW. Yeah, so heads-up display. And then I start with this example is that looking at the car side of things. Um, Again, it's like so simple and so straightforward. And as I said, there's no spatial element here, obviously, but for me, this is a demonstration of how critical we're going to actually find augmented reality when it does become widely popular. Because I had an example a few months ago. I was with a colleague and we were in a car. He has a BMW that has heads-up display. He'd had it for about 6 months. And we were in a different car that did not have heads-up display, and we were doing a road trip to go see a customer. And my colleague, Andrew, he spent the entire 2 hours of the ride complaining, like every 30 seconds, how dangerous it was for him to have to take his eyes off the road to look down at the dashboard to see what the speed was, or to look off to the side at the navigation that was in the center of the dashboard. He's like, this is terrible. And yet what he's been asked to do by not having the heads-up display is drive the way all of us have driven all of our lives, where yeah, you do have to take your eyes off the road to look at key car information. And so, but it was a demonstration of, once we start getting this kind of information into our visual field so that we do not need to remove our eyes from the world around us, we will become hooked on it very quickly. Andrew's complaining certainly convinced me of that. And BMW has already, I think it's later this year, if they're not out already, they're going to be putting exactly the same information into sunglasses for motorcycle riders. And I had a chance to experience these at CES, and they're fabulous. They're really fabulous. Again, no spatial component to this. And so the question when we see something like this is, where does the compute go? Anytime I see any kind of XR implementation, I always ask, where does the compute go? Now, in the cars, obviously it's in the cars, and in the glasses, actually, I'm pretty sure it's just in the glasses, but there probably is I've forgotten, I think it's I do know this. It's a Bluetooth connection to a smartphone, which is going to be, a very standard thing as we're going forward at this particular stage of development. But when I was at CES, the Consumer Electronics Show in January in Las Vegas, I also got a chance to see another one of BMW's current works, and this is a concept. It's their augmented reality ride concept, and this one is spatial. So in this, I was sitting in the passenger seat of the car. It was a driver who was not wearing glasses, was actually doing the driving. And I had a pair of X-Real glasses, and full disclosure, there was a cable running off of these glasses to a smartphone, which was being manipulated by an X-Real guy's backseat, right? So it was, this is definitely early concept kinds of things. This is, not going to be a product anytime soon. However, even though, I had a whole human being sitting behind me manipulating what I was seeing, the experience on the glasses was astonishing, because what BMW had done was they'd taken navigation information, embedded it spatially, apparently in the visual world outside the car, and it was persistent. So this is us. We actually left the CES parking lot and drove a big loop around Las Vegas and then came back in. And so this is us leaving the parking lot, and you can see these arrows on the left. They were persistent as we drove by them. And then as we came up to the stop sign highlighted when the car actually drew too close to some kind of external barrier. Then kind of this big wall came up to indicate, where you're getting close, you might scrape your car. It was fantastic. And again, early days, obviously, it'll take a lot of regulatory approval before a driver would be able to see this kind of information. But this is the exciting world of spatial computing that off-device processing brings. Because because I was asking the BMW guys and the X-Real guys, all right, where's the processing happening for this? And yes, a lot of it was happening in the smartphone, but a lot of the anchoring was actually, there was a unit that was in the car as well. So when you've got, a big thing like a car, you can actually add compute to it really easily. And so this starts introducing us to the concept of, in our lives, as we are moving through our daily lives, spatial information, both for entertainment and for information. And so another example, because we've got a lot of stuff in our world around us that is already here on smartphones. And so the Minnesota Twins, for example, if you're attending a game at their home stadium, you can look through the Minnesota Twins app on the smartphone, and when a batter comes up to bat, you can use the smartphone to show you the last 10 hits that batter made and where the ball went each time. And this is, and for those of us who know about spatial, this is pretty significant. Oh, and actually shout out to Matthias of Immersal, who will be speaking later. Matthias, I know that you did this with T-Mobile for, I think, the Seattle Mariners as well.
Yep.
Yeah. So, so this isn't the only. You're not the only people, and you may be talking about that a little bit later. But the thing is that the computation of this and the rendering of this is going to vary for wherever you happen to be in the stadium. And so, there's a lot of lift that's going on here in terms of the computing work. And right now, this is being done in a smartphone. And just the naturalness with which we accept this kind of information in our world. People who watch American football, if you watch American football on TV for the last, I don't know, decade and a half, the blue line, if you see that little example down on the left, the blue line and the yellow line, which show both where the play is starting and the goal, that yellow line is where where they're trying to move the ball. Those are purely augmented reality. Those are overlaid on the field in the same way that you get advertising digitally overlaid on fields in European football matches. Americans, quite often, it's gotten so ubiquitous and people accept it so readily that quite often it's become a thing where people go to a live football game for the first time and they go, where's the lines? Because they don't realize that augmented reality is providing those. So, this is all to say that there is so much power in having augmented reality give us information in our lives that once it becomes available, I think it's going to take off really big. So, question, where is the compute going to go? And now let me fold XR into this before we start looking at the compute, because of course that's where all of this is ultimately trending as well. XR will not be fully a standalone thing. Generative AI mixed in with it is going to really, really give us superpowers. And so, as an example, we have Meta's glasses. They're glasses that they came out with a year and a half ago with Ray-Ban, that are look like nice normal Ray-Bans, and they have cameras in them. And up to now, all they've really been doing is taking pictures and taking video and stuff like this. But Meta has announced that later this year, in the United States only to begin, first, they're going to give audio access to generative AI. And then later, probably by the middle of the year, they're going to actually then bring in the ability to add the visual feed from the cameras to your conversation with generative AI. And so this is the example that Meta gives. Look and tell me what fruit this is. You say to the glasses holding up this blobby thing, and then the glasses will use the visuals, do its generative AI search, and come back with audio in your ear. The fruit in the image appears to be a breadfruit. If you have not experienced this kind of thing, again, at CES, I saw examples. I was able to experience this from actually companies other than Meta. There's a lot of small companies that are working on their own homegrown versions of this kind of experience. It is a flippin' superpower to be able to look at something and ask and get audio, only audio for now, responses back. And then the next wave to then actually start incorporating some of the visuals that we saw from BMW and from the baseball game as the next steps down the road. This is the path that we're on. So again, where does the computing sit? For the Meta example, currently they're actually running on a Snapdragon chip that is physically located on the glasses. But everybody in the development space goes, yeah, you know what? That's not enough. Oh, actually, sorry, one more example. Yeah, okay, this was one of the small companies that I met. I want to give a shout out here to Zen Labs, because they took the Meta example and went one step further. They added a low power sensor from Prophecy, a French company, just above the top of the iframe here, that did eye tracking. So these glasses, this was actually literally the most mind-blowing thing in new tech I've seen in a decade. So you didn't have to specify what you were talking about in a cluttered, busy visual environment. You could just look at something and ask questions about it. On a menu, you could look at the name of one particular dish and ask questions about, oh, is this spicy? Without needing to say, what it was. Amazing, amazing, amazing stuff. This is actually fully going to transform the relationship between humans and computing, and it's going to develop over the next decade. Okay, back to the question, where does the computing sit? Now, I don't know how many of you guys saw this, but just last week, Google had announced that they were going to be, they've got 2 Pixel phones, 2 Pixel 8s. One's the normal Pixel 8 and one is the Pro. And they were supposedly, designed for AI. And they were going to be running on board the Google's Gemini Nano, their generative AI. But Google announced, what, it's not going to actually come to just the regular Pixel 8 because there's not enough RAM. 8 gigabytes of RAM, not enough. So it just overloaded the phone too much. It'll come to the Pixel Pro, which I believe has 12 gigabytes of RAM. And so, yeah, so basically running generative AI on the end device takes up a huge amount of RAM. And, let's just imagine what it's going to do to the battery as well. So there's, even though a lot of the pressure and a lot of the things that we're seeing right now are moving towards putting cut down versions of generative AI, large language models or inference models on end devices, there's a tension here between end device computing space, RAM, and battery life that I think is going to pressure that computing to come back off of the devices after these early days where these models are relatively small and put them back out into the network. And we actually saw some of this at Mobile World Congress, where Vodafone, working with Qualcomm, actually created, this is they were marketing it as a concept. We'll see if they turn it into a product, as their hyper reality hub. And this is an off-device process or off-device unit meant to sit in your actual physical location. So this is not in the network edge, but in your physical location to do the off-device processing needed so that you can actually have a good experience on your headset or other wearables, whatever they might be. And this, this may be a possible solution for in-home, in business. They were looking at both enterprise and consumer use cases with this. But of course, this doesn't address the mobility question. And, so fundamentally, everything that we're seeing is tending towards higher functionality, higher computing needs, pressures moving off the devices and into some kind of something. Having something, a puck at your waist or, the smartphone, that's limiting. Moving it off device into your environment is also limiting because you can't leave the house and still have this work, which leaves the network. So we're going to be seeing, yes, many different solutions for this problem, particularly in the near term, as the business models and the computing models are open. But I think the inevitable trend is to actually move things into the network, which is, why we're all here today. Because when we actually get generative AI combined with the ability to show spatially information that is coming from trusted sources or or the open internet if you're into that, this idea, and I have to credit VTT of Finland for giving me this idea. The idea of having, right now, there's augmented reality implementations where the chief of operations can actually walk down a factory floor and look around and get operational information from the IoT devices running the machines, which is great. But they're not the only ones who might want information about the machines. And so the idea that having within your corporation generative AI being able to access your corporate information in a trusted way because it's behind your firewall, and then being able to have a spatial representation, which makes it easier to understand rather than just getting rows in an Excel spreadsheet. So now on the factory floor, you can have this theoretical CFO view where the CFO is walking on the factory floor and she says, okay, and you can tell that I created this with ChatGPT, don't look at the details, it's kind of dodgy. but hey, show me the return on investment for each machine. Show me the profit generated. Show me the profit generated by the widgets that each one of these machines is making. To be able to get a much deeper insight into that and as you walk down the hall, being able to see that information displayed. So being able to give you that much deeper insight in a way that is integrated with your visual space and generated on the fly. This is something that you don't have to actually have your data scientists whip up for you, 3 days ahead of time. This is the kind of world where we're going. And I'm very excited that our industry is part of it. So key takeaways then, spatial computing, generative AI, and gaming all require significant computing support, which goes against the desire for smaller, cheaper, longer battery life end devices in all 3 areas. And we're actually seeing people in the industry already running into computing constraints when smartphones are used, just smartphones or pucks. I mean, come on, who wants a cable to a puck long term? When things like that are used for off-device processing support. And so off-device processing located in the near network, as we see in enterprise implementations with on-prem processing, located in the near network, it's already essential. The need is going to grow. And so long-term, our industry, quite frankly, we really need to step up and start providing those opportunities for edge computing, because you know what? The developers are ready for it. But it's a bit of a chicken egg thing, so which we're going to get into in the discussion later. Because here's a really important part. Filling this need is going to create a whole new element in the value chain. It's going to create new opportunities for revenues, for ownership, for relationships with end customers, and basically it's going to create all kinds of opportunities, disruptions, and even threats. And whoever gets there first and starts creating this environment first has the opportunity to define it. So that's something that I'm very excited about. And so with that, and going, way over time, so we'll have to manage the time a little bit from here. Apologies, everyone. Nurit, I hand back to you. And I believe Santari is up next.
Yeah, exactly. Thank you very much, Leslie. It was very exciting, and clearly the network, the resources, and the location. It's all about location, right? Contributing a lot and have the potential to contribute a lot here. And by this, I want to move to Santari, which is the Metaverse Initiative lead in ELISA. Please go ahead. Can you share?
I don't have the privileges yet.
Okay,
yeah.
let me.
You have to make me a presenter.
Yeah, and Nurit, are you doing that?
Yeah, I made it.
Okay, great.
No, I made a mistake. 1 minute. I almost make you the organizer, but now I make you the presenter.
I wouldn't mind.
Yeah.
You're welcome.
Oh wait.
You got it now?
Yeah, I need to. Yep. Give some privileges to my. Okay.
I'll disappear for the moment. See you again at the panel.
Thank you, Leslie.
Go to yes. Just 1 second. I need to do a bit of a.
Yeah, you know what, Santari? I found that I had to put it into slideshow in PowerPoint, and that was the problem. That was how I got it my slides to show after they weren't showing.
I have to close this program and reopen it to be able to share. This always
you're
happens.
running into the same thing. Okay, that's what Josh was talking about.
Yes, I'm very sorry. I gotta do it.
I spoke with Lauri before the meeting and said at least one will do it, and now Santari is the first one.
Yes. If somebody has their presentation already at the ready, I don't mind switching because I have this hiccup.
Well, go ahead and do it, and we're here for you.
Okay, I'll be right back.
Okay, I'm actually opening the slides. I should have it also, but.
Okay.
That was fast.
Now I shall be needing those privileges again. Okay, thank you. I got it. And then, yes. Wait on this.
Yeah, Sandra, I think you've got them. I see that you.
Can you hear me?
Yeah.
Yeah.
Also see you.
In one share. So
Yay.
I hope you see this correctly. Yes, it looks
Definitely.
like that. Yes.
Actually, can
Okay.
you try moving? Can you try forwarding to one more slide? Yeah, there we go. Okay, it's working. Yeah, you're good.
It's okay. All right.
Yes. Thanks.
So thank you. Yes, it didn't take that much time, but sorry for the hiccup, and thank you for inviting me to speak. And thank you for the introduction already. So my name is Santeri Suominen. I'm the Metaverse Initiative Lead at ELISA. And in this presentation called the Metaverse Pulse Check, I'll focus mostly on recent XR hardware developments and what implications that might have for the general competition environment in XR, and application focus areas, and what might then be the future directions of this market. And a few words about ELISA before we go into that. For those who don't maybe know, we're a telecom and digital services company operating in Finland and Estonia as our core markets, and then internationally in over 100 countries. And we are also rated among one of the most sustainable companies in the world. And our mission is a sustainable future through digitalization, so that is a very good thing for us. This winter, we started offering the first 5G standalone subscriptions in Finland to our consumer customers, and with that, also the metaverse as a digital service domain and paradigm for three-dimensional computing is an area which offers very interesting potential use cases for these advanced connectivity services. As I spend a lot of time communicating this topic to various stakeholders within ELISA and externally as well to our customers, I often encounter that the cold fact that explaining metaverse in concise yet understandable terms, which still capture its wider range, is a challenge. But this roughly is the technical perspective we use to take on the metaverse and the social phenomena that are generated within that framework. I find the concept of metaverse still very useful due to its holistic sort of value chain approach to how a 3D computing paradigm, however we wish to call it, XR, spatial computing, etc., as it emerges. So, and to find these interesting phenomena from these technologies of Web3, Gen AI, 3D, and XR, we need to dig deeper into the crossroads of these key technologies and see how they converge today and in the future. So I made this little thought exercise recently after Apple Vision Pro came out, and I made this very rudimentary sort of thing where the y-axis is about form factor, so size, shape, weight, battery placement of devices, and the x-axis is then UX elements. Basically, holistically, UX, user experience, comes is a subjective term, but it usually comes from elements like resolution, field of view, lens quality, color depth, spatial audio, graphics, content, OS, ergonomics, and so on. But the end result is like an experience that comes from that. So I tried to place some of the recent devices from recent years into this crude sort of a graph, and the reason why I chose these two as the axis is because they are the main elements that force compromises on the other. So if you have a sleek form factor device like the Meta Ray-Ban, for example, which is very lightweight, very nice to wear, it usually doesn't have that many UX or sort of like features that can play into a very great user experience. Of course, this is always relative, but still. So it's a sort of trade-off between the two. And the Apple Vision Pro absolutely feels like it's starting a new era in XR hardware. So to quote ex-Oculus Hugo Barra, who wrote in a blog that it's an over-engineered dev kit, which it definitely is, but it also shows definitely the new gold standard of user experience for head-mounted computers, essentially. And although I see that they have a very significant technical and design advantage over rivals, it would be quite interesting to see what the other major companies in the market could achieve with a similar price point of a device. But also the Apple Vision Pro made me realize that, no matter how advanced the technology within the headset is, the user experience that needs to culminate from these technical elements is what makes all the difference, and it's very hard to achieve. So kudos to Apple for that. But anyway, after coming out, the sort of intensifying of the XR competition after the launch has been very nice to see. So that's clearly one of the best things that came from that. The costs of creating this XR market have been very high in R&D, and the return of investment has been quite small so far. But now at least it feels like everybody seems to be a little more concerned again about their place in this paradigm shift in a very early phase. So although the competition environment is not as urgent as Gen AI these days, everyone is still trying to find their place again in the trenches, so to speak. So some of the good things are that public perception, I feel, about XR or spatial computing is changing because changing from the 2016 days into today with Apple Vision Pro, and that's a huge favor to everybody. Then, of course, there have been new companies founded to capitalize on the potential software development opportunity that this brings, and other very interesting things. But we are seeing some interesting alliances in the market right now with Meta and Microsoft, and Meta and LG, and everybody's sort of like making these new partnerships here and there. And it definitely feels like 18th century European diplomacy, if you know what I mean. But the long-term question, of course, is that which platform now seems to be most appealing to not only users, but developers at this point, and where all these critical business applications are being made. And it's worth noting that usually terminology in this space is mostly branding language. In the recent years, we've been hearing about VR and AR and XR and spatial computing and mixed reality, and all the companies sort of use these a bit haphazardly sometimes. And such, this language has sometimes little significance on actual device performance or features, but sometimes the different branding terms might actually just be indicators also of what a certain device is striving or a platform is striving to be. So when we think of the term spatial computing and what Apple is trying to communicate, that it's worth looking at the App Store and what kind of content is available. And it's much less gaming focused than the Quest Store, for example, and it reminds me sort of the iPhone and the iPad App Store. So it's more like seems to be heading towards a more, I think they've also said this, a more sort of general purpose new computing paradigm. And there's utility, entertainment, learning, gaming, fun little curiosities here and there in the App Store. And it's not an ideal game device used due to the sort of the at least for fast-paced gaming, due to the input method that it has with hand tracking. But it's really an interesting platform. Also, it seems like now we've seen a lot of these smaller or much more lightweight AR devices, light AR glasses coming out, which might, one of the use cases has been this sort of like third screen or maybe second screen gaming, so that you have these light AR glasses and you can play your mobile games with it. But also a spatial computing devices, like bigger device, can do this too, obviously. So if we want to look at maybe this one sort of summarization of the device landscape at the moment, we are seeing at least these three classes. But I like to put this in these three categories. So on the left we have the heavy spatial computing, XR, VR, AR, full user experience headsets. On the right side, we have the most light form factor smart glasses, which might not even have a display to them, like the Ray-Ban Meta, which is the sort of the ideal generative AI and smartphone companion device. And as Leslie showcased in her presentation just now, the sort of multimodal AI support that you can get to your everyday tasks by looking at things and then asking, hey, AI, what is this or whatever. That's going to be really interesting to see whether that breaks through. And not only Ray-Ban Meta, but for example, Brilliant Labs frame glasses, which are relatively new, which also have a display, are also in this category. And then in the middle category, we have these, still quite light devices, but which have more of these AR capabilities, holographic displays, and sort of sometimes some devices might have these generative AI features, but also they are used frequently as a big screen to carry with you. So sort of an and I think in the large picture, if you look at the higher part of my slide, we can see that of course, these heavy devices are going to go down in form factor, and then there are going to be more better user experiences in the most lighter category, and they're going to meet somewhere in the middle. So it's going to be really interesting to see what kind of advancements are going to happen in this light AR category over the near years. I think still, if we are aiming for a device, well, okay, I'll come to one point a bit later in a later slide, but this is how I see the landscape right now. So if we think about then some potential killer apps with this kind of mobility in mind, which comes from 5G, for example, then in the lightest category of the devices, this sort of multimodal Gen AI in smart glasses, which uses sort of mobile broadband to communicate with the AI model, which is run on the cloud, and then it's just streamed back to the user. We are, the device space for that is already forming up, and it's going to be really interesting to see how people adopt this to their daily lives. And I think the challenge might be then how to, at least in enterprises, is how to combine this sort of way of working, that you have your AI glasses and you can sort of use those as, take your handwritten notes, and how to put that into your digital space, and how to sort of bridge this real world and digital workflows into one. So what kind of output you can get from this companion AI, what kind of usability you can design into that is going to be a key question. Then in the middle category, this sort of like gaming on the go, and especially cloud gaming with these light AR glasses is really interesting. So one device, for example, the Viture, I don't know how to say it, Viture 1 AR glasses, they are they have this interesting use case that you can stream your Xbox and your PlayStation games into that device. So you can, take your controller with you. You have your AR glasses, and like they have a computing unit which is put on the neck here, and you take those with you, and you can play your PS games on the commute. And that obviously requires very stable, very low latency, high bandwidth communications. So whether that becomes a major use case in mobile gaming, I would keep an eye out on that, especially. But then the last category, where the communication and the network requirements are the most hefty, and also maybe a little more development needs to be done is this very high demand applications in industrial metaverse, for example, which require hybrid rendering, for example. And recently in NVIDIA's GTC conference, there was an interesting use case where hybrid rendering, so partly cloud rendering, partly on-device rendering for this sort of e-commerce for cars was being showcased. And this is one of the reasons which makes me think that on-device compute is not going to go away in favor of cloud computing, but the more compute there can be also in the device, that's still going to be a big thing. But we're still have to see some kind of solutions what are happening on the edge as well. So really interesting thing. And one very hefty use case for that for consumer applications could be these sort of holographic calls with your friends. So you could bring sort of a virtual version of your friend into your location, and they could see also what you see. That requires a lot of streaming of data, very low latency, and very big computational capabilities with the device and on the edge. So yeah, these are some of the interesting use cases for me, at least. So to finish off, some food for thought. Still, where are all the 5G classes? And we've been talking about this for years, that 5G and this kind of wireless networking technology is going to be a game changer for XR, but currently even still no device is directly supporting it, which might, and to, it's part of the chicken and egg problem that Leslie also described, but what could be, the solutions is an interesting question also. Also, what would be the use cases that people really want? That is an age-old question, of course, and we have to do a lot of prototyping and testing for that. Obviously, we can't know it beforehand. But I hope that we won't have to be waiting 5 or 10 years for this to mature significantly. And I think that this kind of heavier spatial computing XR headsets are going to be a thing before that. But maybe a way forward could be to get a really interesting reference design from some company or a combination of companies, which could put together some sort of key specifications for a device which would live from edge computing, cloud computing, and 5G. So the specs could be somewhere in the territory of weight in about 150 grams, 100 grams, which is still pretty good for decent ergonomics. The highest field of view optics possible. I think the light AR glasses currently suffer from small field of view, which is something that's been a thing in AR for quite some time. But to somehow to get that up would be really great. Then some very light onboard computing for final rendering, and then mostly, designed in an edge, very well working edge cloud environment to work with offloaded rendering mostly. Maximum battery life, and of course we would need a smartphone as a companion device, which would handle the data traffic. So and also to have less computing and battery on the device itself that you wear on your head. And then some kind of ultra fast wireless connection between the phone and glasses, maybe WiGig, I don't know. I'm not the expert on this, but I'm looking forward to having conversations with other people, whether this could be a way forward. But these were my thoughts on the topic, and looking forward to the panel discussion and everybody else's presentations now. So thank you very much, and on to the next one.
Oh, wow. Thank you, Santeri. It's very, very interesting, and I agree that we need to look at the killing applications and the requirements, and to understand what we need to do in order to support all of this. So this is very interesting. And by this, I would like to move to John from Verizon. John, I'm making you a presenter. John is the CEO of Media and Entertainment in CTO, I'm sorry, of Media and Entertainment in Verizon, and he will talk about really what the example of the edge of the network has enabled spatial computing by improving performance and security at the same time. So please go ahead.
Right. Let's see what we can do here from a sharing standpoint. I think I'm going to make it happen. I think this is going to work. Let's see. Hey, everybody.
Yeah, that's fine.
All right. All right. So I'm going to have a pretty different and interesting view here. Thanks for having me. I see folks out there who I know. I really appreciate it. And so far, this has been incredibly interesting for me because in my role as the CTO for media and entertainment for Verizon, I am where basically Verizon connects with the customer, right? And I do a lot to connect partners and the industry back into the machine that is Verizon, and don't always get to spend as much time as I like on the standards and the development side, but end up, because media and entertainment is, I think, the best use case, for all these new technologies. I end up being able to spend a lot of time thinking about, how do we implement and what we can do here. So let me kick off with this, Frost and Sullivan. Verizon is doing a lot. Verizon, is an organization that spends a lot of time with 3GPP, spends a lot of time. Do you hear me okay, Nuri? Okay, just making sure. I saw you pop on. Spends a lot of time, investing in our network. And if you look at, in particular, my area of specialty, which is media and entertainment, there is a huge amount of investment that Verizon is doing. And when you compare it to, like, let's say, the capital that the broadcast space commits on an annual basis, Verizon spends more on, us building our network and our capability than the entire broadcast industry does combined on an annual basis. So this slide is really to show you that there is real desire, real demand for edge. There is this kind of enterprises thinking about how to leverage edge, and I think there's a lot of M&E applications for edge. When we think about, and I'll go through one today in particular, but when you think about, what used to be server-side ad insertion, I talk a lot about advanced advertising. Think about the fact that was, cloud-based server-side ad insertion. I really think all of that is now moving to the edge. The edge, has all these attributes that makes it way more applicable when you're thinking about how to build out your business model and what you're looking for in a low latency, standpoint. And so it doesn't just mean that edge for distribution. We also talk a lot about edge for contribution. And one of the really good use cases that we've had on the contribution side is around live video and basically electronic news gathering, where we were looking at protocols like Zixi and others and enabling the decoding, like in an example with live view, where you take a video camera, you connect a 5G modem to a live camera environment, and then that live camera environment is bonding back at the studio, or bonding and debonding in the cloud. We did some testing with live view where we were doing the debonding at the MEC, at the edge of our network, and you really see the performance. You see the jitter go down, you see the latency go down, you see the overall performance and retries all go down, and it really makes a significant impact. Now, when you think about Verizon's implementation of MEC and what we're doing in this space, obviously, you guys know back in 2019, Verizon was on stage with our leader, Hans Vestberg, and Andy Jassy of AWS, and we basically did the first ever 5G edge compute platform announcement in the world. So imagine, kind of where we've come from 2019 all the way to today. The other thing I want you to think about is, what our goals are around gaming and streaming. And I'm going to dive into that with really enabling QCI around it in some of these slides. So let's go to the next slide. Okay, so one of the applications that we are in heavy testing with a large game company right now is ultra low latency matchmaking. And that's leveraging AWS's Game Lift. This is a really cool application of where we are seeing edge compute and the ability to have it go and do matchmaking in real time. And it's not just simple matchmaking that we are testing right now. It's actually matchmaking that's looking at network performance. It's looking at the performance of individual UE, seeing what they are. Does it make sense to match them with another UE that's having a similar performance experience? And so that's a very interesting concept that we're now working on. Other things to think about with the ultra low latency matchmaking is it's running in wavelength zones. And so that is, if I'm going to assume everybody knows, but I'm sure we'll have some folks who don't. When Verizon went to implement its edge compute kind of model, it partnered with AWS in a product called Wavelength. And those wavelength zones we deployed in our SAP sites across Verizon's macro network. And what that means, and the reason that Verizon did this, is it means that if you're a software developer, if you're a game developer, if you're an XR developer, you can, and this is now for years, go straight in and use your cloud implementation, use your code that you're already using in AWS, and really push that right out into a wavelength zone. And you're able to choose what SAP sites you want to push your code into. And so that's pretty exciting. That allowed Verizon not to have to build out its own custom API, but leverage a widely accepted, we'll call it API ecosystem with AWS that then allows that to go, kind of straight in. And that means that not only are you seeing Verizon leveraging use cases like ultra low latency matchmaking, but you're seeing our customers and AWS customers just going and playing with it without having to reach out to Verizon to make it work. That's a super important thing to realize. And I don't think everybody understands that this capability exists today through the wavelength zone product at AWS. And you can pick the networks. And that's not just for Verizon. There are partners on a global basis. I'm sure there are also partners on this call. So that can create a pretty incredible experience when you do that. Okay, so next slide here. All right, so one of the things that really early on we realized with our implementation of the wavelength zone, which you can see in the middle, is that you still have to be able to support devices that are not on your network. And so in this example, we're talking about, what is MNO, interoperability, given enterprise customers capability, not only to unlock the benefits of wavelength, but also when the customer might be on another cellular network as well. And so we have done a fair amount to make sure that there's still an experience that is going to be there for that wavelength zone implementation, not just only in our own SAP site on our macro network, but outside the network. There is a lot here when you think about the SAP sites and being able to get to edge compute. Think about when I talk about location aware content, and that you have content that knows and needs to know where it is being delivered and where the devices are that are receiving that content. And I'll give you an example of content that never leaves a stadium or venue. Content that gets custom created inside the venue, and it's really for the fan and for the experience inside the venue. And so think about content that is being produced maybe in a production truck, behind the scenes. Maybe it's the digital team, maybe it's a broadcast team inside of a venue, and then that content going not out to the cloud, so to say, not really out of the building, but being able to go to the macro network, being able to go to the radio heads, and then being able to stay within the four walls of that venue, and then being able to deliver back into a unique experience that enhances the fan experience. These are all things that are super relevant to the MEC conversation in the M&E space right now. So what are some of the challenges here? I mean, I think, dual connectivity, once you, and again, I'm speaking to an absolute, aware and knowledgeable audience here, but the normal customer, the normal partner that I'm talking to is not working on the standard side. And so so when you say, hey, listen, dual connectivity can be a challenge. So what we're thinking is, and what we've started to play with is being able to do, single connectivity to a UE. And I'll show you a slide coming up where once we create a profile, basically like a QCI 89 equivalent, we call it a QCI 133, a custom profile, that it really is a game changer from a dual connectivity standpoint. Obviously, connection around congestion points, it can be a challenge, and obviously queuing, and not just queuing, but traffic shaping. We want to be able to make sure that when we think about, and the last speaker talked eloquently about this, when you think about content that is being rendered in the MEC, content that is being just displayed by the UE, or vice versa, game experience being, actually created and it's just being rendered, all of these drive network performance and our team to really think about, okay, what can I do to make sure that it's got the lowest, buffering, make sure that that packet has the lowest jitter. Let me show you this slide. This is a great slide to show the testing that we've done between QCI, where we start to think about video, and QCI 133. And if you look at this slide, this real life testing that we did with a very large GPU chip manufacturer highlights the benefit of what we're speaking about with 5QI, with QCI in a custom profile. We did this is 2K content that was at 47 megabits a second, a private QCI, and in the radio heads, and we were modifying the SPID, or sorry, the SPID with the 5G NR for an RFID of this, for this type of content. And we were seeing at the top, you can see a lot of I'll call it jitter, and you can see how much that got cleaned up with this custom profile, this specific profile. So giving us a better ramp for the start of streaming, more capacity and more stable capacity with lower overall delivery of packets, and all in supporting streaming UDP. So that was really, basically to reduce throughput spikes and remove And part of this is we removed in this test dual link for buffering, and we reduced the overall schedule time in the network. Anyway, there's a lot there to understand, but you can tell with the greater scores at the bottom how better the performance was. We also, and I'll just throw this out, are working on a lot around traffic shaping. We're looking at SCONE and some other capability right now. I think that's pretty much it for me. And I look forward to having this conversation, with you, and feel free to reach out.
Okay, thank you very much, Josh. Very interesting.
Thanks for having me. I really appreciate it, Neri.
Of course, and you will also participate in the panel soon. Of course, you talked a lot about the quality of service and the dual connectivity, etc. And definitely, I can also remember now that we had really exciting exposure from MEC about throughput guidance that actually estimated the bandwidth and the downlink and can help to, first of all, optimize the transport, but also to match the coding to the bit rate, to the actual bit rate, and do it in real time. And also to have support dual connectivity and help to select the appropriate link based on the available throughput guidance that is available at any particular moment. So it's really exciting to see how we can really connect the dots here. And I'm looking already for the panel, but before that, we still have a few presentations to go. So by this, we will move to Matthias from Immercell, a CEO, and he will talk about edge computing applying to today's gaming market, a case study. So let me make you a presenter.
Yep, that would be nice.
Yeah, it's mandatory. When we have edge computing, maybe it will be done automatically. Yeah, okay, you should be able to speak. Okay, and share.
Perfect. Can you see my screen?
Yeah.
Perfect. Hello, everyone. My name is Matthias Koski. I'm the CEO of Immercell. Few words about myself, company, and then I will show you a couple of use cases where we have used edge computing. I'm typical Finn. I used to work 10 years for Nokia and Microsoft. I was first based in Espoo, Finland, then moved to London, then to Shenzhen, China, and also recently in Hong Kong. And now back to Finland, where we have low taxes and beautiful weather around the year. About Immercell, we used to be a small startup, then Hexagon from Sweden acquired us. Hexagon is a big corporation from Sweden. Market cap is about the same size as Nokia has nowadays. We are mainly working with the big guys, including like Nokia, Qualcomm, Verizon, you name it. Then, so what we do, basically we enable most of the XR applications, or our kind of VPS, visual positioning system, enables XR applications. We divide those in 3 different parts. First is spatial mapping. Spatial mapping means that we will take lots of pictures from the environment, combine them, send them to a cloud service. It will generate 3D point cloud that can be then used for visually positioning users within the map. This map can be used on mobile phones, tablets, AR glasses, or it can be used by robots if needed. Then, of course, you have the missing part, which is the most visible part for the users, is the 3D content. Spatial maps can be done only by using a mobile phone, or then you can use these fancy 360 cameras for different kind of industrial use cases. On the left is handheld device. Then one of our customers is using these Boston Dynamics dogs and Leica scanners to scan nuclear plants. As you can't send people over there, they just deploy one of these robots and it will it will scan the space once a day. And someday, when it's not working anymore, they just leave it on the site. They can't use it anymore because there's so much radiation in some point. And then, of course, these fancy drones. When we are talking about spatial computing, typically we mean this kind of 3D point clouds. So when you have done the scanning part, after the cloud service has processed the data, you will get this kind of like map with full of small dots. And these dots are like 60 by 60 pixels, unique features in every picture. So let's say if you take a picture of blank wall, there's no features, but if you go outside on the street, you can see these unique features that can identify the streets where you are. So basically, you can then use the spatial map for this kind of future experiences. So someday we will have AR classes on the streets. You can see 3D content overlaid on top of real world. And the key thing in this kind of things is low latency, high bandwidth. So if you wanna sync perfectly the physical world with digital world, the latency has to be really slow, really small. And then, of course, when you have lots of people in the same space, there has to be huge bandwidth. Then a couple of use cases. This was done last July in US. It's a MLB home run event in Seattle. So they used our tech together with Hawkeye system to illustrate like how the ball flies, who is playing, where they are playing, and who is pitching the ball, and you name it. You can see different kind of stats about the game. And then, of course, basically the next step could be that, let's say, if you want to order beer or food on your seat, the crew will know where you are sitting. Then these use cases are from Japan. The right one is made by Rakuten. Most of you might know them. They are like Amazon of Asia. The idea was that they have a real race, and then you can combine that with esports. So you have esport drivers on the point of sales, and they are competing with the real race cars. Then you might have some people on the racetrack, and they can see both cars driving through their mobile phones or AR glasses. Then on the left, you can see one example from Nissan Stadium. The idea was that you had 7,000 people in the same stadium, and they can interact with each other. So there's lots of data going back and forth. First, you have to scan the environment, then you get the point cloud, and then you can start building the experience. Here, the idea was that people can send greetings to their brand, and then these text messages flow in the air. They will formalize the logo of the band, and just before they start playing, it will explode. Then let's move on to industrial use cases. This was done with one of our partners in Finland. The idea was that you have a physical world, and then you combine that with BIM models. With this building information modeling, you can see in real time where is all the pipes, cables, assets, and then let's say facility management people, they can tag different kind of like service requests, or employees can then also like report if they see something is incorrect or there's like, let's say, some kind of leakage. Then of course, like very simple wayfinding as well. Then horse racing. So kind of like we thought, what would be the new way of enjoying live events? So we thought about horse racing. Before you arrive on the stadium, you can use wayfinding to find your own seats. When you are in the stadium, then you can see the race through your mobile device. You can see kind of like who has the biggest chance to win the race. Then you can see who's leading the race in the real time. And then, of course, you can do live betting. So the idea is to improve the customer experience and also create more revenue for the stadium. You can upgrade your seat and, of course, order food on your seat. In most of the cases, when people are using AR and spatial computing, it's typically they want to gamify something. And the idea is that you have a location-based experience and they want to drive food traffic in the right place. Let's say if you want to do something for the kids, you create an experience in front of the Lego store. Once they have finished the experience, then they will go inside the Lego store to buy some like toys. Then it can be also used for urban planning. Let's say you want to show how some buildings will look like when it's ready. You can have like a poll. People or citizens can vote that what kind of option is the best for the city, and then the city will build the best option. And some of you might recognize the place, the Shibuya Crossing from Japan again, and the idea was to create a game for tourists. So once they visit the place, they will spend more time on this place and then take some photos and videos to Instagram and so on. This use case is from Finland. The idea was to show for people when the site is ready how it will look like. So quite often people see like fancy 3D models about the buildings, but then how about the surrounding? So it's like one of the key selling points for customers to see how the place will look like when everything is done and finished. Then a couple of examples about buildings and maintenance. In the small window you can see on the left, facility management software. There can be like navigation to the right places. You can choose the ticket, what has to be maintained, and then you just follow the robot to the right place. And once the maintenance work is done, then you just tick the box and go to next item. Something really simple. Then we have a couple of customers who are doing wayfinding for blind people or almost blind people. They are mapping train stations, airports, other public spaces. Just use the mobile phone, look around, and they will get the audio guidance. So basically where Google ends, our part will start. Then tourism, that's quite normal, especially in China. There's a huge metaverse hype and they want to interact with people and tourists. So they are using spatial computing and AR on that. The last example is training. Some of you might recognize the place. It was actually Nokia's booth at Cytex 2 years ago. So you can use spatial computing for training. Let's say safety training for the employees. This was about how to stop fires. And our colleague Dan, who is in the video, is explaining how to use the device. And kind of like last point from my side is that there's 15 billion devices already in the market. So tech is already here. We don't have to wait anymore. That's a quick outlook about spatial computing from our side.
Wow, thank you very much. Really exciting use cases. It's encouraging to see that we already have a nice amount of objects here, and the opportunity is just ahead. Okay, we will explore about this later.
Thank you.
So thank you, Matthew, again. And then let's go to Philip now from HoloLight. He's a Senior Director in XR Streaming in HoloLight.
I believe that Mathieu is next, actually. That was just Matthias who spoke. And then we have
sorry, I'm sorry. Wow, I'm sorry. Thank you.
Yeah. Matthias and Mathieu, very similar names, but not the same
Same
people.
but different.
My fault. I'm sorry. Wow, Matthew. Wow, very good, Matthew. I'm sorry for that. So Matthew is from EdgeGap, CEO and founder, and he will talk about extended reality. Let me make you a presenter. I'm really sorry. We're waiting for Philip very quickly, but Matthew before, and this was Matthias. So thank you very much for that.
All right. Hello, everyone. Let me know if you can see my screen and hear me.
Yeah, we are.
Cool. Thank you. So thanks for the invite. I'm Matthew Dupree. I'm the CEO and founder of EdgeGap. EdgeGap is a startup based out of Montreal, which I founded just over 5 years ago. We work with game studios. We've built a platform to help game studios, and we're going to go through what it means for game studios and some examples. I'm going to start for the first few minutes as to how we typically pitch it to game studios, and that's going to give you an understanding on how we get them to get some interest in edge computing in general and the technology that we've built. So we're telling them that we can improve the overall player experience, because if we put ourselves in their shoes, right, they want to generate as much money as possible from their games. They want to have as many players as possible worldwide. And the way they do that is through providing a very good player experience, and we help them to provide what we call a flawless multiplayer experience. The main product that we've built at EdgeGap is a game server orchestration platform. For those of you who are familiar with wireless network, think of it as a PCRF for edge computing, pretty much. And we've built that along with what we call the largest public edge computing infrastructure available today to run compute power. And we'll go into what that means in the next couple of minutes. So we have studios who use the platform worldwide. They come from different countries. They use and their game is played on mobile, consoles, PCs, but also a lot of VR, AR, and a little bit of cloud gaming. So our platform is agnostic to the technology used by the studios. There are different game engine that they can use, and we support all of those. I'm not going to go into the details of how games are made today, because it's a whole topic in itself, but I'll try to talk about how edge computing can benefit that market, right? So those customers, those studios that use EdgeGap, they come for those main reasons. For the first one is that we reduce latency compared to any of the public cloud due to the sheer amount of locations that we have. The amount of locations is over 600 data centers today, and they're provided by cloud providers, but also CDN vendors, some ISPs. Maybe there's some of you whose locations that are leveraged by our platform today. We provide unlimited scalability for any amount of users, and that's through the amount of locations that we have and the amount of providers that we have, because we're so many locations. You never really know when you make a game from where the traffic will come from, and the system will just scale and get you the capacity needed for the game to work properly in any area of the world. This is a just-in-time approach, right? So you got to remember something. We are a startup. We were initially funded by VCs and investors in order to come up with a commercially viable product, right? So putting ourselves in the studio's shoes, this technology is made in a way where players can benefit from that very, very quickly, because when players are starting their game, they may be sitting on their couch, they may be looking at their phone, and it needs to run very quickly. Coming up with a just-in-time approach was not a choice. It was mandatory because commercially speaking, it had to be sustainable from a budget perspective. But we ended up creating a bunch of solutions for us to start within a few seconds, anything, anywhere in the world. The whole system is completely managed. So the studio will use us as a SaaS platform. There's no need for them to monitor or install or anything like that. So we're not providing necessarily software per se, it's just a SaaS. And we provide high availability through the sheer amount of distributions, as you can imagine, right? I'm going to go quickly on that. These are the main product that the studios will use at EdgeGap that we have. The main one we'll go over today is the game server orchestration and hosting, which is the one that leverages edge computing the most. So, okay, gaming, I understand. Edge computing, we all know what it is, right? So how do you benefit from edge computing from a studio's perspective? Well, you end up with so many locations when you make a game that you could leverage. You don't necessarily want to make a choice. You don't necessarily want to hire a team of DevOps engineers to manage all of this backend. Your studio is making a game. You want the game to be very good, very fun. You want players to play. So we ended up creating this decision-making platform. And what the decision-making platform will do is it's going to pick the best location of all of the locations we have access, and it's going to start the game components needed for the game to work. One thing I didn't mention yet is that those games that leverage EdgeGap are games that are played today. They're not games made for edge computing. It became very quickly clear to us that we had to support existing games and not necessarily build a technology which required creators to make a game specifically for that technology. So we're trying to connect the dots between existing games and new technologies, and that's how we ended up with this. That's why we ended up with this decision-making platform. So how does it work? Well, the decision-making platform, as pretty much as a PCRF, is looking at the context of all of the players which will be involved in a given session, for example. So the context is, what do we know about the game itself, for example? The game may need specific hardware, it may have specific requirements in terms of what it's going to run on and stuff like that. What do we know about the players, right? So where are they physically located? Is there anything that we know about them, personally speaking, that could be leveraged? What do we know about the device being used, mobile, PlayStation, Xbox, PCs, and so on and so forth. And last but not least is, what do we know about the network, right? So network telemetry. So our system will collect a whole bunch of network telemetry well beyond latency and try to come up with the best location for that specific set of players for that game in this specific point in time, right? And the goal being to provide the best player experience for the players. While at the same time taking into account that we may not have edge computing everywhere in the world, right? And that's very important, because what we don't want to do is ask a studio and say, hey, please make a game leveraging this technology, but hey, only the players in North America will be able to play. It's the best way to lose their attention, really. So the system makes the decision automatically based on the players and the context. It deploy the game servers or the game components, and within 2 to 3 seconds, the players are connected, they're playing the game, and they can enjoy the game that was created by the game studios. This is the typical old style architecture that most studios will have or had in the past. They would pick and choose maybe 5, 6 regions out of their preferred cloud vendor. And in each of those regions, they would have multiple instances of their game components and game servers waiting, running, and standing by for players to connect. So there's a lot of not unnecessary overhead, and there's also a lot of centralized element to this, right? What we're proposing them is to have this kind of architecture where the servers are not scaled horizontally. They're not scaled vertically. They're scaled horizontally all over the world. So are we really reducing latency through this? A lot of the cloud vendors, most of them are partners of EdgeGap, will argue that the network is fast enough to coverage the metropolitan areas and stuff like that. And I'm not saying they're wrong by any means, but I'm just saying that players are spread all over the world, right? So looking at two real case scenarios, these are two AAA studios who use EdgeGap. Okay, on the left side, the studio is making a game which is a 1 versus 1 game, and their previous cloud providers was providing them a data center in Washington State. The two players were both in California. So both players who were in the same state had to connect to a game server, a game component located in a different state. And by using our technology, the platform ended up picking a location very close in San Jose to where the players were located, right? So we've reduced latency by 60%. Now, may not seem like a lot, but from 74 milliseconds to 29 milliseconds of latency in a fast-paced games, that's a lot. In fact, no, you don't need to be a pro player to see the difference. And on the right side, the other AAA studios is making a game which we call PvE, so it's a player versus the enemies. It's a co-op game, so you end up playing with your friend, and we play together against the enemy. By using EdgeGap instead of their previous cloud providers, which was AWS, we ended up reducing latency for 95 of the players, right? So we reduced latency by 58% of the players, which is very important. But it's also important to note that the majority of the players had latency reduction, even those who were seen as people to whom we could not improve things, like people in the US, for example. We could still improve the experience for those players. This is a new, we've been seeing a trend in the last few months where we get more and more VR and AR studios or games. It's one of our latest customers who launched their game not too long ago, and I thought that I mentioned them here. So it's Arcadia.tv, and they're making a dodgeball AR game. So I'll let you imagine that fast-paced, very fast-paced games, looking for sub 10 milliseconds latency, leveraging edge computing is key in their operations, right? So it's in early access, and they're one of the many customers using the system, but they're looking for that. They're looking for something above a standard hosting providers, cloud providers. EdgeGap in numbers. So we have over 300 active studios using the system today. And the active studios are a mix of what we call indies, so independent developers, AA studios or AAA studios, the AAAs being the world-renowned studios that you're familiar with. And it's a mixed bag of things, and they're going to come for different reasons based on their size and the game's genres they're making and stuff like that. We leverage over 600 data centers today from a lot of different providers worldwide. There's over hundreds of thousands of game servers being deployed and managed on a daily basis with millions of players playing worldwide from all countries. We are the first, what I'm calling street edge, where we deployed actual game components in an edge computing environment, publicly played by people. It's in London. It's by Colt. If you're not familiar with that, just let me know. But it's something that's really cool. I'm very happy that we were to take part of that, because we're moving away from the server farm building data centers to smaller footprint to get in the UK is a very good example. That's about it. And then I guess we're gonna talk throughout the panel.
Yeah, thank you very much, Matthew. Very interesting. Of course, gaming is very exciting, and the role of the edge is important there. Let's continue with now Philip. Yeah, sorry that I was wrong before. So Philip, please go ahead.
So yeah, thank you. It's my turn. Thank you for having me. My name is Philip. I am Senior Director for EXA Streaming here at HoloLight. And we at HoloLight, our mission is we want to unleash the potential of extended reality. So first of all, we are focusing purely enterprise. So now we have to get our mind a bit out of consumer and gaming, and let's look into enterprises. So what does enterprise do with extended reality? In the end, basically everything, like they can use it. Like in any vertical, in any department, there is use for extended reality, and these use cases are proven. Some examples are down here. So we have visualization of 3D CAD data, which is a big one. For example, we do this with BMW, where they visualize prototypes instead of building them a lot of times, just to save time and money. Another one is, for example, you see there in medical, you can visualize CT scans really in 3D, which is much easier than to analyze them, opposed to having a 2D screen. You can do this mid-surgery, you can get your data. So there is a lot of use cases. But as you all know, like extended reality right now, it's not like everybody's using it every day, even though the value has been proven and the return of investment, people are sure about that. And why is that? If we want to deploy extended realities use cases, there's three very important factors. First of all, we need a very high performance because, so you can see my screen?
Yeah.
Okay, because just somebody was asking. So
no, I'm sorry, I cannot see it. So is it possible that some people see it and others no?
Yeah, because I can see it.
Okay.
I can see it. Maybe stop sharing and start sharing again.
Sure.
Yeah, sorry, Philip. That's
no worries. Thank you for pointing it out.
I know this.
So it's cool that at least somebody listens and looks at it.
I know it's kind of yeah. We're out here. We're out here.
Is it better now?
Okay. Can people see it now?
Yeah.
I see. Pietro says.
Yeah, no, the thing is, yeah, we have to. It's not presented as it was for the former speakers. That means it's like if you don't share your screen, but as someone pointed out, we see it from your camera.
Well, yeah, there's we can see Philip in the camera, but then I can also see his slides. He's an inset in the slides.
Same here.
Okay, so then we can continue, I think, right?
Yeah, please.
Perfect. So yeah, if we want to deploy XR to coming back, there's three very important things. First one, high performance. Why high performance? Because in general, industry is used to powerful computers. So their 3D data they have, and usually it's about 3D data, whatever you want to do, is very heavy. It's something you, most of the time, you cannot just deploy on a mobile device and render it. I mean, otherwise they wouldn't buy these incredibly expensive computers for their engineers. Second, and that's something which is often overlooked, it has to be easy to use. There is no value in the use case if your workers like need a physics degree to find a way to use the stuff, right? So it needs to be in a way that I don't need to study using it. It needs to be really, really easy. And last, it needs to be highly secure, because if we are talking all of the time about data, about what we want to visualize, also the people before me, like the 3D map scans, this is very, very sensitive, in particular in enterprises. Like it's one of the most valuable assets they have. So if one of those gets lost, this is a huge, huge issue. And let's have a look how we can solve these. So first of all, the easiest way to solve the performance need is streaming. So streaming means we don't render on the XR device. Actually, we don't do anything on the XR device except displaying. And we put everything else on a cloud or edge server and put all the processing there, and the device becomes a display. So all sensor data gets streamed up to the server, and then the rendered image gets streamed down. And there is a few technologies which are called streaming, but we want to focus on pixel streaming, and that has a few reasons. First of all, pixel streaming is the only streaming technology where you don't need power or calculation resources on a device. Like if you stream 3D data, the device still needs to render, still needs to calculate, and still needs a lot of power, which the mobile devices usually don't have. And even like HoloLens, Quest, and Apple Vision Pro don't have enough power, and they are not even close to the form factor we would like to have for XR, right? So that's a major issue. The second thing is pixel streaming doesn't put any 3D information ever on the device, because even if it's just stored there temporarily, I mean, we know that you can get videos out, you can record them. There is always a way to get temporary data out. So that's a security issue. But if the data is never transmitted, there's also no way to get it out. The third one is, which is nice about pixel streaming, is you have always the same bandwidth. It's constant. It doesn't matter where you look. It doesn't matter about the content. It can be as complex. You have a steady bandwidth. And this bandwidth, you can control a bit by quality. And that helps a lot when we work together with, for example, Nokia, because we can then leverage a lot of 5G advanced APIs like L4S. Because since we can, with the bandwidth, like in a normal video, reduce quality, go up and down, have it very steady, the network on the other side can work really well with it and give us low latencies. Whereas if your network load is very spiky, you get into a lot of congestion issues on the radio. And then last but not least, it's very easy to integrate and develop, because for developer, they don't need to know anything about it. They don't need to think about it. They just need to insert an SDK and it does its job. And yeah, that was the performance part. But now I said, like, it has to be on a cloud or edge server. You have to deploy it there. You have to connect there. That doesn't really sound easy. So we have a product on top of the streaming solution. It's called Hub. And Hub is what makes it easy to use, because Hub in the end does in the backend all the orchestration you need. So if we are on Edge, Edge has the Edge servers have Hub deployed. All you need to do as a consumer, you go on the either website or you open the Hub application in whatever device you want. And then it looks like a store. You see it in the background, and you can just open any application. So it's actually easier than using an app store, because you don't need to download anything. It's just like you click on it and it automatically starts. And everybody can use this. And I think that is one of the most important goals here. And in the end, the most important part here today, I think, is security. And there I want to go a bit more into detail. Why is this whole system so secure? I already started with the first part. The data is never stored on a mobile device, because the problem is you cannot secure a mobile device. I mean, we want to have as small as possible glasses. Small glasses means you can steal them. And there is not really a way to make sure this doesn't happen. And also, you don't need to steal the whole glass. I just need the chip with the information on, like basically the hard drive out of it. If I know where it is, I can get it out. And that is the one important thing which is already solved by streaming. But then we also want to be sure that we have here a server connection. Nobody is breaking in there. And this is where 5G comes into place, because Wi-Fi in general, you can hack. There is ways to spoof Wi-Fi passwords and so on. For 5G, we know that's very, very hard, or basically impossible. You need a SIM card. And I can selectively, if I lose a SIM card, I can selectively deactivate it and it cannot access the network anymore. So let's say one of the devices gets lost. First of all, it immediately, as soon as it's out of range, loses connection and there's no data ever on it. Additionally, if I figure out it's lost, I just need to deactivate or disable the SIM card, and there's no data leak happening, and it cannot happen. And then due to the 5G network in between, you can also not really attack the communication in between the edge server and the device, which makes this a very, very prime solution. And then the edge server, again, that doesn't need to be where I am. So I can do that one in a place where it's secure. Of course, I need to still make sure nobody steals the edge server, but that's much easier than to make sure nobody steals an edge device. Let's summarize this to look at the full architecture. So this is how, in the end, the whole deployment looks. So we have XR applications which are not ours. So we have one, it's HoloLight Space in that case, but we built a whole ISV ecosystem because, as we saw, we want to enable the whole XR industry, and we are nowhere near experts in every field. So that's why we work with a lot of ISVs like Frontline, like Tactile, to provide us with the use cases and our customers, more importantly, to do their stuff, right? And what's very cool about this, if you as an end customer get this platform, you immediately have all the software there. You don't need to find a way like, oh, I want to have this training software from there. It can do everything already thanks to the ISV ecosystem. It's basically like an app store, right? Nobody would use an Android or iOS phone if there was no app store where you can get stuff, because an empty platform is worthless. Below there, we have the streaming SDK, which is basically the enabler of streaming. It's important for app developers. They can easily integrate it, and that's how we can onboard these ISVs. And if that's in there, you can put it on the hub platform. And then this hub platform, on the one hand side, orchestrates the edge servers, and on the other hand side, over the 5G network, connects to the headsets. And the cool thing is also, for you as a developer, you only develop targeting the platform. You don't need to care about headsets, because as soon as it's running there, the headset is a display. And the nice thing is then, what display you use, also you don't care which monitor you're plugging into your computer. But yeah, that sounds very good in theory, but let's look at, is this already reality? And finally, we are allowed to talk about it because there was a press release in December last year. And exactly what I just showed you, we did together with Lockheed Martin and Verizon, and showcased this also in San Diego last year, and Lockheed Martin is using that. You can find the source of the press release there if you're interested. How it works is, there is a local 5G network bound to our edge computer. Everything is streamed, so we can be sure that the data is always handled and secure, and we have always full control of what's happening. And yeah, besides the ISVs, Lockheed Martin uses that also for internal apps. And I think it's very cool because it shows that this is not a marketing solution or marketing slide. This is really already in use. And it's also in use quite some time, because you can think like getting a press release of those guys, that takes a while. So yes, finally, I told you about what we do. I want to quickly also tell you like who we are as HoloLight. We are a startup. We were funded in 2015. Our headquarters in Germany, in Munich. But we, in addition, have an office in Innsbruck in Austria, and very important, also in the US for our US operations. And we are right now already more than 80 people. We are approaching 100 soon. And yeah, we work with, I think, a lot of important partners, with Nokia for having access to this 5G API, so that we can give people a very good experience over cellular networks. We work with AWS for cloud and on-prem. We work with a lot of operators like Verizon. And yeah, we also have a lot of clients from the industry. BMW, we already said so often. That's why today I wanted to show you the Lockheed case, or talk about that one as far as I'm allowed to, because it's also much more showing the security aspect of the solution. That's it. Thank you.
Wow, thank you very, very much. Very interesting. I think we are ready to go for the demo, live demo, but I must acknowledge that we have seen some before. But let's see now the one for visual positioning in events. I think it also has to do with immersive. So by this, I want to invite Larry, that is the head of ecosystem development in Nokia, and the network is code. So Larry, let me make you a presenter.
Thank you.
Okay, I hope the screen is visible.
Yes, it is.
Excellent, thank you. So my name is Lauri Alho. I've been working for Nokia roughly 5 years now, and I'm heading the ecosystem development from 2 points of view. We have a sponsored arena multi-sport venue in Tampere, Finland, where I'm based, and I'm heading the ecosystem development in the Nokia Arena context, creating new showcases, which I will refer in this short demonstration also. Then I'm looking after the ecosystem development for Network as Code, especially in Europe markets. So those are my daily tasks and activities. Just before demonstrating the Network as Code, let me quickly summarize what Network as Code is all about. Because we live today in an ecosystem world, it means that many companies utilize building blocks by other companies to build their solutions. If I would take an example as an Uber, the taxi driving company in this use case example, they have used AWS to scale up globally their backend systems. They used Twilio to automate 6-digit SMS messages. In their platform, they use Braintree for automating any payments in the Uber application. And when they want to show the taxi and your location in the application, they use Google Maps. But the problem is that there isn't any simple SDKs or building blocks currently exposed to software developers that would provide a rich amount of 5G-enabled capabilities as easily consumable as any other technology for the third-party software developers. And we as a Nokia want to bridge that gap by bringing a new set of toolboxes to the software developers. What it means is that we want to change the relation between applications and networks. So nowadays, applications are seen more like over the top of the existing networks. You hope for the best that the 5G connection works, but there is not much that you can do to dynamically program or get information from the 5G network. So we want to change that and give software developers access to the underlying 5G network capabilities. And it means that there should be new innovations and agility of the developer ecosystem, better new applications, optimized use and monetization of the network, which is very important for the CSPs when they do 5G network investments. Now about the Network as Code, what it means in practice. In practice, it is just a web page, a portal for the software developers. And we have it publicly available from this address. What it means is that around 15 minutes, an experienced software developer should be able to skim through the page, see what capabilities and features we have available, and of course, go through the documentation which we have available. I would say it is in industry standard way for software developers to integrate these Network as Code capabilities into existing applications. What Network as Code in practice means for the software developers, let me play a video which was just published yesterday. And please let me know if the music is not playing during the video.
Today we're here at Nokia Arena with Capit Systems to test Nokia's Network as Code quality of service on-demand capability. I'm excited to show you that with Network as Code QOD and Capit Systems Cloud Production, we will have an excellent stream.
We specialize in providing high-quality, uninterrupted broadcasting services, often in environments with high network traffic. Our focus is on leveraging the latest in 5G technology to ensure a seamless live stream, whether it's a sports event, a concert, or corporate conference.
We are setting up the wireless cloud production unit. Let's see how the network holds up.
Looks like we have now some quality of service issues.
Let's activate the quality of service feature now. And just like that, we see how the video streams flawlessly into Capit's cloud production system, showcasing how Network as Code streams and integrates without any problems into Elisa's 5G network. Let's switch on the quality of service on demand for the downlink side. Okay, now the session is created and we can see there is no anymore any buffering visible.
By combining network as code and 5G standalone slicing in live events, it would become possible to enhance the end user experience during live events, as seen in demonstration at Nokia Arena. One of the key expectations from Nokia Elisa collaboration is to accelerate innovation through the network as code framework.
Today we saw how we can leverage network as code's quality of service on demand capability to dynamically adjust our cloud-based production quality. This feature allows us to prioritize our data on the network, ensuring high quality wireless production, even when thousands of users share the same 5G network.
Right, so that was one of the example use cases where we utilized network as code in Nokia Arena. And now in this view, I can show you how the developer in practice uses the network as code. I have now here a Python code editor, and then I have a live Android phone currently located in the Nokia Arena. And we can see that it is just 3 lines of code to request a live location of this device. So the first line that I have to run is to import the Nokia's developed software development kit. That can be just downloaded when you have the Python installed. After that, you need to create a client object, and it means that once you are registered to the network as code portal, you have a private token which needs to be used so that we know who is trying to authenticate to that platform and do they have consent, for example, to request that specific phone's location. Then it is a third line of code if I would like to request the location of this phone, and it is not through GPS, but it is through the 5G cell location info that is available directly from the CSPs. So now when I run this line of code, it takes a couple hundred milliseconds to request that, hey, where is this device located? And we get as a response the coordinates and then the address. It is in Finland, in Tampere, in Kansikatu. And if you would like to print or show the location in Google Maps, I can, with a predefined function, pull the coordinates and show it in the Google Maps so we can see the exact location of the device inside this Nokia Arena. And this could be maybe very beneficial in situations where GPS is not available, so especially in indoor environments. And I can show you that when I get the location of the another phone, which we have currently in the Nokia Arena, it is connected to a different 5G cell. So as we can see, once the device connects to a separate cell, of course, we can get the different location of that device. And that could be very beneficial information in this kind of visual positioning systems to understand where the device is located. How it happens, what is the flow exactly when the device is requesting or the software code requests the location. You can see it from here. So the application, the Python code editor, sends the request into a network as code backend system. And from there, based on the phone number, we know that which CSP it belongs. And then we route the request to that specific CSP's 5G components network exposure function, and from there to access management function to get the information that in which 5G cell that specific device user equipment is connected. And then that information is routed back all the way to that Python code editor or in the real applications into the applications use. And this, of course, beneficial from many point of views, just to mention a few. If you have IoT devices, those might not be able to be located due to the lack of GPS chip, or maybe those needs to be so battery efficient that you cannot transmit any additional megabits from the device itself. And the beauty of this device location use via network as code is that all the data flows happens in Nokia's network as code instance and the CSP's 5G core component. So there is a zero interaction with the user equipment itself. So that's about the device location use case. And then I can show you the quality of service on demand live demonstration. So let me show you here the phone once again. In this quality of service on demand example, we can start a speed test in our phone in the Nokia Arena. So this computer is currently in the Nokia Arena. I'm remotely connected to that, and then we have a remote connection to the phone in the Arena. We can see we achieved just a couple megabits downlink. Due to the congestion, there is quite a lot of background traffic ongoing. And now we can see that in the Python code editor, it is a couple additional lines of code when we create a device object with our phone number that is currently in use in this device. And then we just need to specify the IP address, 10.9253.58. And as soon as I run this, create a new QoD session, it dynamically goes into the operator's 5G core to request a higher quality of service for the device. So let's see, now when I run it, we see instantly 30 megabits downlink for this device because it gets a higher priority when compared to the other traffic that is happening in the background for this device. Then we can see the status of that just initialized session, and when we want to remove it, we can run device clear sessions. We are back to the subscriber's traditional priority and data plans and so on. Another example is that we can have live video stream coming, and we can see that it is at the moment buffering quite a lot. We can just wait a couple of seconds and try to see, can we even get a glimpse of the video? It seems to take so long that now we can see it, but it's constantly buffering. Now we have this IP address here, and once I run it, it is just a couple hundred milliseconds, and that specific connection between the device to that server's IP address gets a higher priority. And of course, this could be run dynamically. If the device identifies that, hey, there are some problems, this line of code could be dynamically run on that device. And then as soon as I clear the session, back to the traditional data flows, and it takes a couple seconds, we can see right away, we are once again getting the buffering because there isn't enough bandwidth available for that specific connection. So that was very short live demonstration of network as code at Nokia Arena. Maybe you can find from here some inspiration how it could be used in the visual positioning and in many more use cases which would require these guaranteed higher quality of service, such as the XR devices and so on. So thanks for your interest. Shall we move to the next one?
Yeah, thank you, Larry, for that. Okay, so I think by this we can move to the next phase of the event, the panel discussion. So we will look at the edge horizons to navigate the future opportunities in spatial computing and gaming. And I would like to invite Leslie to moderate the panel with all of the speakers that we had before. Thank you, Leslie, for that.
Great, thanks everyone. So let's bring all the speakers on camera and on microphone. So everybody, I have to say, what an amazing collection of views of edge and spatial thank you all so much for participating. This has been a really fantastic overall look at the different elements and the different players that are all in this space. And so, so given that we we ran a little bit over time, kind of with me going over time at the beginning, so it's kind of my fault. But let's
fair.
yeah, so I'll take a little bit more time than we were expecting and see if we can get at least 20 minutes of talking here. And so let's start off with Santeri. Now, Santeri, you spoke, thank you so much for your look at the hardware. But one of the things that was a bit of a throwaway line is that Elisa has actually launched 5G standalone. And that faster, more responsive 5G standalone gives more opportunity for edge processing. And I wanted to ask, if there's anything public that you could actually say about what you at Elisa are finding in terms of 5G standalone and the difference that might make with edge computing scenarios. And if, for example, if there's anything in gaming that you're actually finding.
Right.
Okay. Oh,
So
I hear
thanks.
a Finnish voice in the background. Can people who are not on the panel
Yes,
go on
me
mute?
too.
Thank you very much. Yeah.
Yeah, so I mentioned 5G standalone, and I hear that especially after the Mobile World Congress, everybody's been talking about that and what kind of benefits we can bring to our end users with 5G standalone. And I think of course network slicing is very important in use cases where maximum bandwidth and also minimum lag, such as competitive gaming. Or I find that a lot of gamers today are quite competitive, and it was different from the time when I started gaming online, when 100 millisecond lag was okay. That was still good, right? So now today we're talking about much smaller, but in practice, I think, in all honesty, from my perspective, today what edge computing does is mostly with network optimization and stability of the network, and which of course is fantastic in its own right, but that's where we are grounded today. And for example, what EdgeGap has managed to do with reducing the lag, for the effective lag for gamers with distributed servers, that seems very, very impressive and interesting and very practical to me. And but maybe in general terms, the maturity of edge computing and cloud streaming of application is more mature in the industry and enterprise setting. What Philip, for example, showcased. So those are my takes to begin the conversation.
Okay, great, thanks. Does anybody else have any comment on 5G standalone versus non-standalone? Any experiences that you've had or not, or any hopes and dreams? Okay, not yet. Okay, well, anyway, let's actually segue, actually, since you mentioned EdgeGap. Let's go over to you, Mathieu. One of the things when we were talking or exchanging emails before this was that you actually mentioned, which I think is a really key element of all of edge processing, which is this chicken and egg kind of thing. I mean, excuse me. You're out there developing your services, but it sounds like it may be difficult. Not all operators are where they need to be in order for you to work with them. Or how would you characterize the situation with edge computing with regard to where you stand?
No, I think Santeri nailed it when he talked about the chicken or the egg, and the research for the killer app or something like that. We've been facing, like, very early, 5 years ago, we faced a challenge where we could not ask studios to build a game for an infrastructure which didn't exist, right?
Yeah.
And to this day, I still get called. It happened a few weeks ago from a service provider, like a wireless service providers, which I'm not going to name, and they were calling me and say, "Hey, we need the use case to build our business case to build an edge computing infrastructures," and I was like, "That's." I mean, we somehow can provide some pat of info about that, but it's if you don't build it, they're not going to come kind of deal, and they're not going to build something specific to a new type of infrastructure if it doesn't exist or it's very hard. And that's why we ended up shifting toward, okay, how do we get existing games and benefit, but if there's no such thing as an edge computing, can we still make the most out of any situation? It's very hard. It's very hard. I don't know if for those of you who were at Mobile World Congress in 2019, Dutch Telecom had this at their booth. They had it was Mobile Edge within Dutch Telecom booth, and they had a game where you could play within Mobile World Congress. It was kind of a cool, a novelty, but infrastructure wasn't there for anyone to commercialize that game, right? So I think Niantic looked into it a bit, and they do have. I mean, it doesn't need edge computing, but it's definitely. So yeah, connecting the dots and making a clear path toward that is going to be key here. And you're not going to build it if there's no reason for if there's no killer app, but the killer app won't exist until you build it, kind of deal. It's very hard. So it's a balance there. I think that initiatives with enterprise will definitely help toward that, since it's much more localized versus the gaming space, which is worldwide. And yeah, that's our take here.
Yeah, I mean, I think what I'm really getting, looking across everybody here, is that this is an ecosystem play. This is, there's no one entity that can make this happen on its own. And anyone who does think that is in for a rude awakening, because we all need to work together on this. And Josh, actually, let me throw this over to you, because Mathieu is yeah, little out of order here. Let me toss you this one. So Mathieu was just talking about the applications not being there until the infrastructure is there. But from what you described with Verizon, you actually are working to make the infrastructure there. And so do you find that that has encouraged developers to come and work with you to build on your environment, or are you, is that a problem that you have in order to actually attract the developer community and to build the ecosystem? Like, what activities are you doing to actually
Yeah, I
build
mean,
that system?
100%. It's a great question. I think here's my really happy moments when somebody comes up to me at an event and says, "Hey, we were doing this, this, and this on your network," and I knew nothing about it. And that's really where we're starting to be. That's when you know the ecosystem is there and is starting to grow, when you find out only after the fact, and they're like, "Hey, download this app. It uses your edge compute capability on your network." And you're like, "Oh, killer. This is great." And so that's what I look for as an indicator. And I do think it's there. I do think that's starting to grow. Now, does it still need optimization, tweaking? Is there stuff we still need to do for the network to make it work as most effectively as possible? Yes. But the first signs of people using it, going to AWS and ordering up a wavelength zone and just starting to play with it are there. One of the other things I wanted to mention, Leslie, is there's a great combo that Verizon and myself are very supportive of, which is it's not always just edge compute. I think a great combo is open caching and edge compute, because a lot of times you have some decision being made about content, and the content can be cached through an open cache, open caching node that sits also right there at edge compute capability.
Yeah, Josh, I think you've actually raised a really important point here, which is that as the architectures shift, ownership and business models are necessarily going to shift as well. And the focus of today is really a technical talk, but we could actually have exactly the same conversation looking at this from a changing business model perspective, because that's actually, the open caching that you just brought up there, that has all kinds of ramifications behind it for ownership of content, for facing the customer, and things like that. Yeah. Josh, let me, Matthias, let me move over to you now. From, you're definitely part of that wider ecosystem, being able to provide that spatial awareness for, you've got the network application over here, and you got the network over here in the application, and then the spatial stuff. How does edge computing fit into the things that you're actually doing? And what particular benefits or challenges have you seen working with edge at Immersal?
Yeah, kind of like the key requirement from our side is always low latency, high bandwidth. So once we have the MEC servers on duty, then like it helps always in these big events. You might have like 50,000 people in the same place. Some of them are using Instagram, some of you watching like YouTube, Snapchat, you name it. So kind of like there's a really high bandwidth required and low latency, of course, when you are combining real world or physical world with digital world.
Okay, and what are the ways? I mean, are there ways that you actually today are working with this, or are you like working individually with each particular use case to find solutions for this?
Yeah, we are actively working with like Nokia, of course, and telcos like T-Mobile in US, all the Japanese telcos, they are using our tech, and then kind of like trying to find the best solutions and best ways to optimize the tech during the live events.
And so, and then that actually sounds like a lot of effort on your side. So the kinds of like lower effort, at least for the intro that Josh was talking about, sounds like a pretty helpful helpful development. And the kinds of low touch stuff that Lauri was talking about as well sounds beneficial. Yeah. So, Philip, over to you. Now you have built a really strong value proposition around off-device processing that protects corporate IP, shifting to the enterprise side. But one of the things that Santeri pointed out in his presentation, and of course we all know to be the truth, is that there's really not that many 5G devices out there. So, the question was, where are the 5G glasses? So how is it that you at HoloLight are able to actually provide 5G connectivity and pixel streaming? How are you actually solving that 5G glasses question?
So that's a good question, and there we are back to the chicken and egg problem, which we try to solve there with intermediate solutions. So what we do is we can connect 5G modems or just phones to the devices over wires, which is not the nice solution, but it shows the demand for these 5G glasses. And yesterday, for example, I was at another panel where there was also Qualcomm, and they showed they already have reference designs for 5G native glasses, so they are coming up. But since hardware is always a bit slower than software, it just will take a while. But in the meanwhile, we can already set it up, because otherwise we're running into the same issue. Like then the devices are there, and then if we start to develop for them, it's too slow. And already today, there is no alternative, because it's not like you have another way of doing XR in this case. On device, first of all, security, no. But second, no device is powerful enough to do this. And you cannot use Wi-Fi in a lot of these environments, because Wi-Fi is not enough. And also Wi-Fi is very bad with content and scalability, because like 3 devices, a Wi-Fi hotspot is done. And that's why they don't have another way to do it. So that's why they are okay with this intermediate solution. And that's how we can lay the path to going forward.
Yeah, and I know that one of the considerations, one of the constraints right now from the device manufacturer side is that a 5G module still pumps up the price of the headset when they're trying to drive the price of the headset down. So we've still got a lot of development to do. There's still a lot of physics problems to be solved. I for one am, I see all the movement that's happening in the industry, and so I'm looking forward to seeing what's coming in the meantime. But I think, Philip, you're right. It's interim solutions. We can all see what's coming, and I'm particularly, this particular grouping right now. You are all people who are not waiting. You are going out there and actually solving the problems of today, and creating the interim solutions that will be the stepping stones to the better future. So I salute you all. Yay.
Hey, Leslie, can I just add something to that, which is, at least for Verizon, and I think for others, this is like the year of the API. If anything, there's a lot of the carriers who are now truly embracing API level interface for this UE. And that is, I think, the underlaying kind of tone that's going to set the real capability for the year. however the device is connected, if you can get to the API, you can let that API know this device is a special service, whatever it's going to be, network slice, all these different things that we're all aspiring for. And I think it's projects like Kamara and 5G Future Forum that are starting to help define some of that and want to throw out.
Josh, fabulous point. Year of the API, that's actually fantastic. And of course, we've seen APIs available. Telefonica, for example, they've been doing network APIs for a long time, but it hasn't quite taken off yet. Yet I think we might actually be reaching a critical point here. From your point of view, since you brought this up, what do you think has changed to actually make the APIs?
Yes, so it's only going to that investment is only going to happen once they see a business models for us, for Verizon, that actually support the investment, and it's now becoming absolutely obvious. I also think, and again, I'm just going to open up another complete can of worms, I really think that this is becoming 5G versus Wi-Fi, and I think we're really seeing this kind of macro trend where devices are, device manufacturers are going, hey, maybe I'm going to put a 5G radio in a device instead of a Wi-Fi modem. That, again, we're a little far out, but that's where a lot of us on this call operate. And I think that's going to happen. I think that's where we're headed. We're going to see 5G as a more secure delivery method. And all of the work we do here is going to enable us to make it a much better experience for the UE than ever before. And that UE is going to be everything from electronic news gathering and 4K cameras to people who are going to be playing gaming at the edge, sitting on a subway.
Absolutely. And the security point, which of course HoloLight is really building a whole business around being able to provide security with AR rendering using 5G as a transport mechanism. That's something that really hasn't gotten enough attention, I think. Making sure that your corporate IP is protected during that transport leg is absolutely vital. Lauri, you are the one person in this panel I haven't called on yet. And of course, you just did a lovely demo of Nokia APIs. Is there anything else that after this conversation so far, and given what you've experienced so far, anything you'd like to add about the reality of working with network APIs and actually making them available to externals?
Yeah, of course. And maybe firstly, adding something when you firstly asked from Santeri about the 5G standalone core and any benefits to edge computing. Sometimes you might even forget the real differences between 4G and 5G. And one thing came to my mind actually later on, and it is the L4S, which also Philip mentioned, the low loss, low latency, scalable throughput capability. We actually demonstrated that at Nokia Arena together with Elisa just a couple of months ago, and it is planned for 3GPP release 18 release and adapted feature, and it is for both 5G core user plane function UPF and then to the 5G RAN available. And I think that is one important capability to bring to 5G networks, because without that we cannot really improve this low loss and low latency requirements for the real-time applications. So I think that's one thing, that even though we would have the edge computing in place, there would be of course some ways needed to ensure that the data flows without any problems. And as this Nokia Bell Labs L4S technology is very great for that, I think the 5G standalone can accelerate and boost up these XR and other solutions once it is commercially deployed to the CSP networks. So that's just a short comment from this 5G SA edge computing. And then,
yeah, sorry, go ahead.
Yes, and well, could you just repeat the question to
No, actually mentioning L4S is actually that was a very good moment. That was exactly the right kind of comment. Yeah. So, okay, well, listen, we're getting close to the end of time. I'm actually going to throw something at you. to close this off, I'd like you to say, just in one sentence, if you could wave a magic today and have something magically happen about edge computing or spatial computing or whatever, what is the one thing you would most likely to magically happen to change this environment and to make it better? And I'll let you each consider that for just a moment. And I'm going to go through you in the order that you are on my screen, which of course you can't see. So Matthias, you are lucky first. What is the one thing that you would do if you could wave a magic wand today and change this whole dimension of this whole market?
Alexa market.
Yes. And well, edge computing market.
I would somehow try to force these big enterprises to be more kind of like aggressive on innovating new stuff. Quite often they want to be just fast followers, but they don't want to be the first ones. So
okay, so giving courage to
challenge.
Customers to go out and build these things. Excellent. Yeah. Okay, Lauri, you are next.
Okay, thanks. Maybe a couple of things, just the practical ones. So of course, more computing power to the XR headsets would be always improvement and nice to have, and even more and more real life solutions. But then of course also having these good ways to have even more throughput in the networks to really provide really high 8K plus resolution streamings from the edge to the XR devices. I think that would be fascinating to have even already today available for us.
Happily, that's on the way, but we'll have to wait just a little bit. Yes. Thank you. Philip, if you could wave a magic wand and make your business better, solve a problem, what would it be for you?
I have two things. One, you already more or less said. It's basically I want to have a device which is 5G capable and really lightweight. So lowest processing power just for doing remote rendering and 5G connected and therefore battery life and stylish. And the other one would be basically 100% 5G coverage, because that is another big issue sometimes we run into.
Good call. Good call. Well, Josh, over to you. You've heard the clarion call for 5G coverage, but what would you wave your wand?
Yeah. Okay. Thanks. Yeah, I hear you. You know what? I continue and spent my whole career, thinking and supporting open standards. And I think this is such a moment that without an open standard that we can deploy across this on a global basis and really make sure that it stays an open standard allows for the entire ecosystem to get built against it, to be successful against it. And I really want to, continue to see an open standard both on the API interface side, but, specifically around edge compute. I want an open standard that supports this on a global basis.
Fantastic. That's a great call. Thank you, Josh. Santeri, over to you.
Okay, I want to go non-practical and very sci-fi with this. So a world where almost all, if not, well, most, if not all, computing is distributed across urban spaces, and so that it's actually externalized from our devices, but into the environment. And so are all the sensors. So basically cameras and everything that can create sensor fusion with AI and create these, for example, global 3D spaces. But what Immersal is doing, but from the user device. But that would actually be part of our urban infrastructure and a significant step forward in creating, let's say, a global sort of a metaverse thing. So that's the first thing that came into mind, like big sci-fi stuff.
He's ready to enter the matrix. Okay, you're ready to go right in, plug into the matrix. I can feel it right now.
That's actually what
I think is ready to deliver it, right?
Yeah, we are doing that. We just need a bit help from Verizon and T-Mobile and AT&T.
Oh, fantastic. And Mathieu, last word to you. What would you wave a magic wand and have happen?
More people to follow Verizon's path into building an actual infrastructure we can leverage, and probably an Apple Vision Pro that don't make me look like a dork. Something smaller with glasses, not big thing that I can walk around and not.
Maybe cheaper.
I mean, yes, also.
Oh, fantastic. It's well, listen, one of the thank you all for your participation in all of today. Audience, I hope that you got some new information from this really fabulous collection of companies. For me, one of the takeaways is the question was raised, you know, chicken and egg. If you build it, will they come? And I think the Verizon example shows that yes, if you build it, and make it accessible, yes, they will come. And I actually throw it out to our industry, the telecommunications industry. If we look at who are the people with the money to build it and who are the people without the money, clearly the operators have more bankroll to be able to make the first move here. And then if you do that, as Verizon has done, then the opportunity for developers to then come and work with you exists. I don't think it's going to happen the other way around. And Josh, you're nodding. So yeah, and actually everybody's nodding on that one, and Santanu, you as well. Yeah. So, well, and with that note, I will hand it back to Nurit. And again, thanks to everyone for participating today.
Yeah. So first of all, thank you. It was very, very interesting, and it's really hard to summarize after such a great summary that you made. And I think the one sentence that each of you provided about the dream, but I think it's not a dream. It will happen. It will be a reality, and it sounds all very, very promising. I think we talked about the characteristic of the edge are very special here, and all the value that it actually provides. We talked about the chicken and egg in terms of the infrastructure, but also in terms of the devices. I think about the shift not only in the architecture but also in the business model, which also talk about the need for collaboration across the ecosystem. I was very thankful for you, Josh, for bringing the E of the API. You know, for us in MEC, it of course very interesting because we are working also in addition to Camara and OPG, really to expose the abstract information that can really help to develop this value-added services to deliver them to the applications. I think one of the aspects that we need also to ask ourselves, what are the capabilities and what data the network, from the edge of the network, we can actually expose really to enhance and optimize the spatial computing and gaming applications. So this is something that we should look at, that top-down use cases to make it global, not local, beyond just enterprise and industrial. And yeah, the future is getting there. Yeah, I will not continue to summarize everything that you actually mentioned, and I would just like to take the opportunity here to, first of all, thank you. A special thanks to Leslie for supporting, to help organizing that with all the great ideas and your keynotes and the great model of the panel. It was really inspiring to see that. And of course, to all the speakers, including Santare, including Josh, including Matthias, Matthew, Philip, and Larry. It was really exciting. I would like to invite you all to help us to look at the use cases, to understand what additional capabilities we need to support from the edge, and what APIs we can expose in order to help the ecosystem here. And definitely we support the open standards as Josh, and we are here to help to make it globally available. So with that, thank you very much. Let's take it to the next learning, and hopefully in the next panel we'll be already be able to say, okay, we made some steps to make it happen. Okay. So thank you very much, everyone, and we will publish some information based on this event, and we will look for the future events to talk to you. Thank you very much.
Thanks, everybody.
This conference is now